What is trigonometry? For us, it's the study of right triangles, which is a triangle where one of the angles is a right angle, or equal to 90 degrees. So the picture is something like this, where this angle here is 90 degrees. The square notation denotes 90 degrees. So if you see this on the CLEP exam, that is a triangle with this rectangular box near one of the angles, this is standard notation for a right angle. So why are these triangles special? Well, the most foundational result for right triangles is what's called the Pythagorean theorem, which says that if I have a right triangle, the lengths of its sides are related in a very nice way. It says that if I have a right triangle, so here, and then the two sides have lengths A and B, and the hypotenuse has length C, then A, B, and C are related as A squared plus B squared equals C squared. So why is this remarkable? Well, it gives us a very simple way to compute one of the side lengths knowing the other two. So what are the trigonometric functions we're going to discuss? Well, they're going to be functions whose input is an angle, and they're going to be defined in terms of sides lengths of a triangle. So you input an angle, and then you compute a quantity based on that angle, but really based on a triangle in which this angle resides. In essence, these functions are defined in terms of ratios of side lengths corresponding to the angle. Now, one of the most essential questions is, why is it enough to know just the angle? Why is that determinate completely? Well, the idea is that because we're taking ratios of sides of a triangle, it doesn't really matter if I have a triangle that is very small or very large. I don't care about the actual size of the side lengths. All I care about is the ratio of the side lengths. The point is that for two right triangles with another common angle, they are automatically what are called similar triangles, which means they're the same up to some sort of scaling factor. So you can think similar triangles are the same after I've expanded it or contracted it. So the picture in your mind should be like this. So here I have a right triangle, and then I'm going to give one other angle, theta. Now, once I know theta, I also know the other angle in this triangle. Let's call it x. Why is that? Because the angles in a triangle sum up to 180 degrees. So x plus the known theta has to be 90. So once I know one angle that's not the right angle, I automatically know the other one. And what this means is that once I specify one angle in a triangle that's a right triangle, it's automatically similar to any other triangle that has the same angle, because all the angles will then be the same. So the point is that if I have two triangles that all have the same angles, they don't have to be the same triangle, but they're the same up to multiplying all the side lengths by some constant. Then the ratios of the side lengths will also be constant. So the trigonometric functions, which are defined as ratios, are independent of which triangle I use. I can use this one, or I can use this one, because I don't care about the actual side lengths. All I care about is the ratio of the side lengths. Having said this, now let's actually introduce the definitions of the trig functions.